unfortunately, I just realised I'm not really going too much into Python in this talk, so I hope no one's coming hoping to learn a huge amount about Python. My talk is kind of more high level about the work that I've been doing the last 3 years on an app that we're developing and have just launched. And the goal, I guess, is to kind of give some information about some of the decisions we made when we were building it, some of the tools that we chose that were good, some that were not so good, and then hopefully some lessons about how to make good decisions. So if that helps, hopefully we'll walk away with some value. So I work for a company called MetroCount, and we do the rubber tubes across the road that you've probably seen. What most people don't know is that that's an Australian-made product, made down in South Korea. We have a little mini factory there where we put it all together. We get some of the plastic boxes modelled in China, but all of the circuitry is done here. We've got engineers down there that are designing and manufacturing them. And we have been around for about 20 years, building that product and selling it all over the world. So we are the kind of, if you see those tubes across the road in London or in New York or anywhere, it's almost probably 99% of the time it's one of ours. So it's come from Australia, been shipped over to there, and they're using our products, which is pretty cool. And so I came on with MetroCount about 6 years ago, 6 years ago, and at the time we basically, I'll start with this bit that's on the screen. So about 4 years ago, we decided we wanted to, well, the CEO's been hassling for a long time, the engineers, to build a real-time traffic monitoring device, which is very different from what we've done in the past, because historically we'd always capture data and then it would go into a single file that's read by a Windows desktop app, and you're doing analysis on one file at a time and then delivering results to the client. With real-time, obviously that data needs to go into the cloud, so there's a whole bunch of infrastructure and things around that we needed to develop. We need to manage a whole bunch of devices in the field through the internet, so doing IoT, and storing huge volumes of data where historically they were just a file on your computer. We now needed that data in the internet in a database to be able to deal with it. Then the other problem at the same time is that we did have all of these historical data files just sitting on people's computers and they weren't using it. So the local government around here would have 20 years of this data that's sitting on someone's hard drive somewhere, and if anyone wants to know how many cars went down that street, how fast were they going in 2 years ago or 3 years ago, it was very difficult for anyone to find that information because it was just not archived properly and it was just a mess. And also it was limited in the way that it was analysed, that you could only look at one side at a time, one traffic data file, so there was no way to go what's happening across the whole network. So I kind of came in, hassled the CEO and said we need to build a web app to handle all this data and present it and make our clients' lives easy, because what would happen is you'd have someone there collecting this data on the side of the road and they'd go, this is site 1, 2, 3, and then they'd leave and the next guy would go, this is site 5, 6, 7. And then in fact it's exactly the same spot, exactly the same location, and it should have the same name. So it's just this data chaos that they've all got, and every local government pretty much in Australia has exactly the same problem. So you go and talk to them, unless there's a rare case where they've had one person do it for 20 years, then they might have some organisation, but everyone else has chaos. So we attempted, the goal was to solve both of these problems at the same time. So we need to have the data coming in from real-time devices, and then we wanted to have all that historical data in one place that you could analyse at the same time. So we built a tool called Atlyst. So we've got clients now using it all over the world. One of the first clients using it was Isle of Man. They were a good one because they've had lots of our equipment for a long time, and so we have portable counters, which are the tubes you drive over. We've also got embedded ones that go under the road surface, and they use piezoelectric sensors and things to basically just collect a vehicle's tyre hitting, bang, bang, bang. Every time a tyre or axle hits that sensor, it records that timestamp, and then that all gets dealt with later and turned into vehicles, how fast they were going, how many axles they had, if it was a truck with 6 axle groups, or if it was just a bus that's the same length but with 2 axles, so that that's the information that local governments and state road authorities need to determine how thick do I need to build a road, and how road safety things, how many people are travelling really close together, and so there's going to be crashes because there's no gaps between the vehicles and that kind of information. So there's a huge amount of information in the data that we collect, a lot of it not really utilised properly. So this is the Isle of Man, and each of these dots here is representing a location on the road that's been surveyed, and so I can go and filter through time here and have a look back at what the statistics are. So this, at the moment we're looking at the speed of vehicles, and we can colour code based on, and it's an 85th percentile speed, which is a common traffic engineering statistic. And so we can look at what is the vehicles between sites where vehicles usually travel between 0 and 30 miles an hour, 30 and 40 miles an hour. So being able to quickly have a visualisation of where are the fast sites. So this site up here is colour coded orange, so it's got a very high speed going on. And we can look at that over time and see how that's changing over time. And then we can have a look through different types of sites. So I can toggle off all of the temporary sites, which are the tube ones, and look just at the permanent sites. And then I can also go and have a look at the volumes of traffic. So if there's high volumes of traffic, if I want to know where there's really low volume versus high volume, I can go through that way. Just go for all years. So
what's a temporary bike?
So we do bike counters for bike paths, and we do road. So basically, it's just whether it's on a bike path or on the road. So temporary bikes are tubes going across a bike path. So when cyclists ride over, it records bikes going across. And then we have piezoelectric permanent bike counters as well that year round. And then classification. So I want to know where there's lots of heavy vehicles on my network. Being able to visualise that gives you a good idea of where there's potentially issues with crashes of trucks and things like that. So you can look at where the higher percentages of those are. And then from there, for each site you can do a really detailed analysis. So if I go through and click through the site, it'll load up a site like this. And I've loaded a site here because it's quite interesting. This is in the Isle of Man. They actually implemented a COVID speed reduction and stopped people from going out. So you can see here, basically from 27th of March, people just stopped driving. So this is each day represented by one bar. And then you can see it's gradually increasing as people are getting back on the roads. And then you can see the speed here just dropped drastically, basically overnight, from 65 miles per hour down to 54 miles per hour. Because they actually had an unlimited speed limit on the Isle of Man, which is one of the few places in the world. That's why they have crazy motorcycle races where people die every year. So it's quite interesting to see that kind of data. So this is what we've built, and we've built tools to get your data in there for the clients.
Nothing
to manage all of your data, to be able to export site lists, which when you're setting up a new counter, you use the same descriptions as you had last year, so that you're not having that data entry problem that they have. So that's the historical side of things. That's what we've built so that we can go and look through all these statistics the clients can get. It's building an easy tool so that even managers and things like that don't have traffic engineering background can get in and look at the information. So that's and then the real-time side of things as well. Looking at, so this is some data from Spielwood Avenue down near our office. And so you can see each of these little bits here represents one little puck that we've put on the road. They're like a cat's eye, goes in the middle of a lane. And so these counts will just keep going up as vehicles go over. This time of night it's probably not very busy. But you can just see there's some vehicles have just gone over there. It's counting up. Anyway, it's a vehicle went over a few seconds ago. So all these statistics are now live, coming in real time, basically.
Just one question on that.
Yeah.
That's
if you sort of make decisions based upon that, right?
Do people
I
make
think you're
decisions?
in- I don't know, you're a public health or you're a ambulance service or whatever, and you're relying on that data. So are there bits within this app that are high integrity and you, or
I mean, because the real-time stuff is so new, we really haven't hit those issues yet. Yeah, ask me in 6 months. So we've got our first deployment of these real-time stuff is happening just next week at Men's Street and Mill Point Road in South Perth, where they've got a new level crossing going in just near the zoo there, because they want pedestrians to be safer walking. So they're putting these new devices right at the intersection, and we're going to monitor for the next year or so to see how the traffic changes over that period of time. So hopefully the speeds will decline after they put this new thing in, and motorists may get frustrated, which is the goal of the whole thing, is to slow them down. So that is, yeah, so that's what we built, and then I'll go back to kind of more the how. So our data stores.
Just a quick question.
Yeah.
Are you competing with anybody else? Because I was just thinking, where does Google get their traffic data from?
Yeah, we aren't really competing with Google. There's lots of products in the market trying to do machine vision is the big one that will at some stage start to take over. The reason why our company's done so well for so long is because our devices are super low power. So you don't need to plug them into mains. Basically, they're totally on their own system. They run off solar panels, and so therefore it makes you can put it anywhere. You can plonk it up, in the middle of the Northern Territory, and it's not going to run out of power, and you're going to collect data continuously from it. So, it's a reliable account of every vehicle that's gone over there. Rather than Google, you're getting a subset of the data that they can get access to, which is good for certain things, like if you were doing freeway monitoring or something and you just want to know what's the average speed of most of the vehicles. But when you're doing road design and you want to know what are the number of vehicles with this many axles so that I know how much wear's on the road, it's a different kind of field. The real-time stuff is new for us, and so that'll be interesting where that goes, but I think we have the benefit that we've got a monopoly in Australia really on traffic data at the moment, and so if we can deliver something in that area that delivers value to people, then I think that will be the real timeness of the new thing we're building hasn't really been explored that much. For people, the installation is happening. It wouldn't really matter if the data came in weekly. It's not like they need it in real time. A lot of people at the moment are saying, we need real time data, we need real time data, and you say, what are you going to do with it in real time? And they go, oh, we just want to look at it. So, that's all right. I think it's important that moving forward, people will find applications for it. So it's a good thing to think about now, and how do we deal with it? Maybe not deal with it now, but have it there for the future.
There's that whole smart freeway idea, right? They're using your stuff?
No, they're not using our stuff.
Something computer vision-y, something or...
Yeah, I think, I don't know how smart it is.
Yeah, neither do I.
But yeah, they've got sensors, they've got radar sensors which are off the road. But again, I think that's a kind of different thing from us because of the fact that they don't care necessarily about every vehicle. They're more about. But we do have our sensors all over the freeway, so you will see them. Just off the Narrows Bridge, if you're going north, they're all along there. But if you see them, they'll be like two thin lines in a row. Once you know, you go, oh, I know about that thing now. I know what it does. So we kind of had a bunch of different requirements for storing data. We needed to store all the status from all of the real-time devices. So what are their battery levels, what's the temperature, a bunch of different information, and then using that for monitoring and alerting. We started off with DynamoDB. We still have DynamoDB in place to store that data. I don't really like it. I've never liked it. I don't know. I spoke to Robin about it, and he said he's used it and it was alright, but I always just have trouble getting you kind of have to do a whole bunch of indexing on different things, and if you want to do aggregate queries, it doesn't work very well. So, that's my finding with DynamoDB. It's good for certain things, but for what we're doing, it didn't really fit the bill that much. We're just about to implement Elasticsearch as a data store for all of our status. and I've been chatting with a few people on the Slack channel. They've given me some good feedback on that. And yeah, that seems to be good, but I'll give you feedback on that later. Then our other requirement, we had huge time series data sets, and we had a whole bunch of relational information about this is a site, this belongs to this organisation, these are the users that can get at it, this is the lanes at the site, this is the array of studs at the site, this is each of the stud at the site. So it's a lot of related information. And the first question when we started the project, I was me and another guy, and he was a lot more experienced than me, and I was getting excited about NoSQL because everyone on the internet was talking about NoSQL. I was like, yeah, NoSQL. But after a bit more research and luckily having someone more experienced, they said, why would we use NoSQL? I mean, the big pitch for NoSQL is, it's infinitely scalable. You know, you can grow and grow and grow as big as you want. You can have it on multiple nodes without, that horizontal scaling is infinite. But in reality, you end up adding issues that you have to think about, like consistency of your data between different, you can have your same data in two places in your database, and you've got to make sure it's consistent, and then you've got to manage that at the application level, which, so I investigated a bit, and we just decided that was not a good option. So then we moved to Postgres, and Postgres brings what most relational databases bring in consistency and having good performance. The reason I think Postgres is succeeding so much at the moment is it's got a huge community that are really involved in it. So as a database, it's just continually evolving and catching up with all of the paid database services. And so that's handled most of what we do. A lot of what I really like is some of the JSON fields in it are really useful, because you can, if you're not using JSON fields and you want to add a field to the database, you've got to write a migration, you've got to add that migration, and it goes through. But if you're using JSON fields, you can just dump data in there and you don't have to update anything in the database level. So things like in an organisation, if you have preferences, you know that preference is always linked to that organisation, so you don't have to worry about a related field. So that's where the JSON fields have been really useful for us.
Can you index on those fields inside the JSON?
Yeah, we don't, but yeah,
Cool.
That's good to know. And you can query on all those JSON fields, so you can do lots of cool stuff with JSON fields in Postgres. The other big thing for us was partitioning, because we've got huge time series data. We needed a way for that data not to just go into one table, and then as it gets bigger and bigger and bigger, we go, holy crap, our queries are ruined. So Postgres, especially Postgres 12, does a really good job of handling partitioning, and the query manager being able to decide if you're querying for data between two time ranges, and it's in, which table do I go to get that data. That's where Postgres 12 does a really good job compared to older versions where it was problematic. You had to really write your queries and tell them exactly what things you needed to get. Anyway, I won't go too far. Postgres 12 has solved some problems for us, and we're currently in the process of restructuring our partitioning structures, and so that'll be a Christmas time deploy, so hopefully no one's using the system. And all the extensions on Postgres, there's some great ones like PostGIS and TimescaleDB. We're not using it either, but good to have them there. For archiving data, so we've got all these events coming in from vehicles, and they're all going into a database for us to go and process them, but we don't need them there for long term. So we've just started implementing archiving off to S3 as a data source. As Ben will tell you, S3 is pretty useful for a lot of different storage of CSVs and things. You can query directly into S3, and it's cheap to store large amounts of data, particularly if you don't need to access that data. So for us, if there's events, a vehicle goes over and there's 3 events come up, 6 events, start end, we turn that into a vehicle record. So that vehicle was going 30 k's an hour and it had 2 axles. And so we turn that into a vehicle. We don't need the raw events to be sitting there. So we've put a plugin into Postgres, which you can write a query, and it stores the query straight into S3. So that's a pretty useful little tool that we've just started using. And it's so we can run that query, store the data, and then delete it off the Postgres database.
That's not like a PLSQL or anything. That's a
No,
straight.
straight into. Okay, so that's the data stores part of it. The front end part of it. When I first started, I was primarily the front end guy, and then the back end guy left, so I had to become the full stack guy. And that was pretty scary at the time. I was the only person running this huge project, and I was like, holy crap! And I considered looking at other jobs for a long time, but I was lucky that I hired a guy that came in that was reasonably experienced. So now there's two of us. At the start I was looking at React versus Angular, and that was the big decision I had to make at the start. The problem that I had with Angular was I struggled to learn it. When I was first learning, I was like, there's so much to it.
Is this 1 or 2 years ago?
One. Yeah, it was pretty nasty back in one. And then I started using React, and it was just really simple, came very easily to me. So that was a decision. I was worried at the time. I thought, oh no, it's easy. It mustn't be powerful. It mustn't be fully featured. But the more I got into it, I was happy, and it's grown into a huge community now. That it's almost a de facto standard. But things will change. Then the next decision we had to choose was a mapping library, because maps are a huge part of our application. And so we started with Google Maps, and we were using a React wrapper library, and it was awesome. Everything was working sweet, and then we grew to about 500 sites that we had in our system, and it all just started lagging, and everyone's going, what's wrong with this thing? So it turns out that React wrapper libraries on native JavaScript libraries can often be fraught with performance issues because of the way the React engine runs, and it's basically trying to constantly update the native library, and you just get all kinds of performance issues. So after some time we moved into Mapbox.js GL, and natively wrapping on that, and that was, there's some really cool features in there that make it super quick. So that page you were looking at before with a couple of hundred sites on it, we've got sites with thousands and thousands. The City of Stirling's one of our first clients, and they have got 10,000 sites or something, and that loads up without a problem and runs really quick. So that's been a huge win for us. We started out with using style components and writing all of our own CSS and everything, and then I started using material design library, and it's just I haven't really looked back since then. You can do so much customization on top of it. So if you're looking for a component library, that's a great one that's got lots of it adheres to a lot of the standards, and it's got good accessibility and those kinds of things. So it's a good starting point. All right, to the back end and the API layer. So I started writing in Express in JavaScript, just as testing out stuff, and I didn't love it, and we quickly moved on. The reason why I was kind of hoping that it would be a good way to go is having JavaScript end to end would have been kind of nice to have a single language. I was a bit worried about Python because I didn't know Python very well back then. But have gotten right into it and pretty comfortable with it now. So it's a different story. So we use Django and Django REST framework in the back end. So it provides pretty easy to model, easy abstraction layers on your database. There's a big community, easy to find all your issues, and there's an extension to do basically anything you want to do on there. So it's been a good choice for us, I think.
How do you find and stop me if you're going to talk about it later, but like the interactions with those advanced Postgres features you were talking about before?
So I was just I don't think I wrote anything on it, but basically we started writing more and more SQL directly, and with the latest big set of changes we're going to do. So previously we had our time series data in monthly tables in the database, and we've found that that's not going to scale forever. So we're changing that into per organisation, and then splitting further on that in different petitions. So we've got multi-layered petitioning. With just time, if you're just going to do 1 month per petition, there's a plugin for Postgres, for Django that handles that beautifully. And sets up all your petitions for you, basically no code on top of it, no SQL code. So if that's all you wanted to do is get monthly petitions, and you know that you've got a data size that's this big and it's going to be that big every month moving forward, then that's, you know, out of the box, ready to go in Django. But when we know we've got data that's this big this month, this big next month, and this big next month, you know, we're going to have, and our monthly petitions, if we kept how we are at the moment, would just grow to the point where it's not going to be easy to query. So we've started writing more and more SQL. The ORM as well, a lot of the queries that Django was producing weren't optimized for petitions. So you've got to make sure, we ended up writing a bunch of, and that might be improved Postgres 12, but we've got SQL now, so I don't know whether that'll work better. But basically, when you're querying big time series data sets, you need to provide, you know, if it's start end, you need to provide the start end to the query, and we were running it through a function in the database, and that was causing problems. So we've now moved pretty much all of our queries on our time series data into SQL directly, so we don't use the ORM for those queries.
So is that a raw database level execute, or is it still using model and raw?
So most of them are raw now. We've got a lot of raw where we use the model, we define the model in unmanaged models that we then go and when we get the data back. But that's not on the time series queries. They're all raw pretty much.
So that's just pure SQL, there's no model around it.
And in fact, most of them now don't even go through Django because we moved to Azure. So we still use, I'll kind of try and go in a logical format. So we made a decision, I made a decision, that I think we needed to use GraphQL. Basically, we had some views in our front end that were going and querying for, give me a site, okay, now give me this related information, now give me this related information, and now go through each of these related bits of information, do more. So we had, you can do things in Django where you fetch the related, but you can't traverse a graph in a REST paradigm, and you end up fetching if you do that where you get the related objects in your Django API, you end up getting all this data that you don't necessarily need. And so we had that problem where I was using promise alls in the front end, and I just had like freaking so many promises. I was like, how do I track all these promises, and what's going on with all these promises? So we decided that GraphQL was the answer, and it seemed like a good answer at the time. So we started with Graphene Django, which was a plugin for Django that basically provides some of the basic library functionality. But it was we probably used it for 6 months, and then just started finding more and more issues with it and writing more and more code on top of their library, and fixing bugs in the library, and it was just getting worse and worse every time we were trying to do anything in it. We wanted to add pagination, we wanted to add different functionality, and it was a nightmare. And that was 2 years ago, so I don't know if it's gotten better now, but I would err on the side of avoiding it.
Why did you go with Graphene?
Because it was a Django plugin and it was easily integrated with Django. We thought that was going to be, you can directly set your models up, and there is some abstraction there so that you just define a model and it creates the API endpoints for it. That was the logic, but it wasn't necessarily the best. And then I started playing with a tool called Azure, which I've become a huge fan of, which basically takes a Postgres database and automatically generates an API on top of it. So there's no application code. You can define all of your permissions, and you can set permissions based on fields in the database. So we have sites, and we can say only allow view access to this table if the owner of the site has this ID. So you've got pretty flexible permissions classes on it, but it's zero code. You're not writing any code to get the whole API. So basically, what we had in Graphene Django, we probably had thousands of lines of Python code. We basically just threw it all away and moved to this automated tool, and it provided huge improvements to speed and it gave us all these things that we were having problems writing, like pagination. And then it had subscriptions, so webhooks where you can directly interact with it, with the API without having to query it. And so it's basically setting up, it's listening for triggers on the database and then firing that data back down to the front end. So you've got this real-time thing that you've got out of the box with Azure that we were in the past, we were polling every couple of seconds, polling the Graphene API, and it was just a nightmare. Everything was running really slow. So, and then I did one query where I had a site and then some related information and then some related information to that, and I ran it in Graphene Django and Azure, and it was 1,000 times, literally 1,000 times quicker. And so we were just like, oh, what have we wasted our time on? But it was pretty new when we started using it, and so I was a bit worried about it. And so it was probably like a few months of playing with it before we were confident that it was going to be stable and meet our needs. So that's been, if anything from this talk, I would say have a look at Azure, because it's a great tool.
Is it self-hosted, or are they host it for you?
No, self-hosted.
So you can run it yourself.
Just a Docker image,
Docker
Yeah.
image, okay, yeah.
and you just pull it down and run it. It's so easy.
Yeah, super easy.
In Graphene's defense, it has gotten better.
It has? And if you've got a Postgres database, then you've basically got an API. You don't have to build anything. It's ready to go.
So it also
Just link up.
does what's it called? It looks at all the tables.
Introspects.
Introspection. Yeah.
Introspects.
Yeah. And then you can choose which tables you want to map into your API. So you don't have to have your whole database exposed. You can just and then you can map functions, database functions. So that's where we've started writing more and more database functions. So we query the functions directly from the front end and get results that way. So complex. So where you were looking back there at, I'll demonstrate that.
The problem with that is that it's a little bit trickier scaling your functions in the database.
So these queries here, so I can set a time range, and I can set the class of vehicle, and I can set the directions and the speeds, and that's filtering through every individual vehicle. So there's underneath that there's thousands of records, and that is hitting a function in our database, running the query and returning results through Azure. So it's pretty neat.
The only problem is it sounds too much like Azure. And
Yeah.
That's what I thought you said. I was like,
Azure.
Azure.
Excuse me. When you show us the filter, those selection are those aggregated result from the unique values, or something that you predefine?
Are they aggregated from that? Let me go back to.
Are those distinct values that you did an aggregate query, or?
We're using aggregate queries. So the values in here?
No, on the top, the filters.
Yeah.
You can see that there are like ranges or distinct
Yeah.
values. Are those hard coded, or are those aggregated query?
These ones are hard coded.
Okay.
This is a default, and the time range is set by what's the latest data survey they've got
Right.
at the site.
And how does that work with, was it called Azure?
Azure.
How
Yeah.
does that work with the JSON field?
We don't use JSON fields for that.
Okay, cool. Thanks for clarifying.
No, we pass those in as parameters to the API.
Yep.
So this is a we pass in here an array of values to filter on, and that goes in straight to the function in the database. I guess back on the last bit, so we still use Django for authentication, and that gets passed through Azure, and using JWTs, and then and so you can encode variables in the JWT, and Azure can use that as part of your permissions thing. So if in your database a user has a certain level of access or a group, then you can pass that through, or whatever you want to pass through to authenticate someone, or not authenticate.
Just before you get
Authorised.
started, just before you get started on this.
Yep.
So are you still using Jenga REST framework for much? Like, have you
Yeah.
found that you've got
That's what I haven't covered, but so we've
Azure for the data and then functionality in REST?
So from the front end, so the only things you can't do with Azure directly are query external sources. So you can't go to S3 and go, what's the bucket name, or give me a short-lived S3 link. So we actually still use Graphene Django for that. We've got like one endpoint for that, but we're getting rid of that. But we've got we still use the REST framework because we've had like a growing requirement from end users to access our data directly. So we're building an API that's got access keys, and that made sense to use Jenga REST framework for that. Just because it's easier to do it that way, and they all want REST framework. So
Is that pre-aggregated data that we're getting as well?
So that's another interesting thing that I don't know. I could go on for I could wax lyrical, but we use roll-up tables to store aggregates. So all of that dashboard with those statistics, all those aggregates are stored. They're not querying the individual vehicles every time. So we were using materialized views and found that that's not a scalable solution for what we were doing. So we use roll-up tables where every 5 minutes, what's the new vehicles, go and recalculate that value for that site. So CI and CD and infrastructure. When we started, we needed to choose a cloud provider because we weren't going to self-host. And basically, at the time, the only reason we chose AWS was because of the IoT functionality. Everybody else had similar offerings in all the other categories that we needed, kind of. And then, but with the IoT stuff, AWS was leagues ahead of the competition at the time. If I was to look again now, Azure is cheaper in a lot of things, and we've kind of gone, should we start to think about switching? But it would be a huge task. It would cost, at this point, our bills aren't that crazy with AWS that it would make sense to look at it. But maybe in a year or so, if we've got growing bills, we might look at other providers, and we might look at other ways to deploy. At the moment, we're deploying all our stuff with CloudFormation templates. So if we were using Terraform or other things, it would make life a bit easier to switch, I guess. Don't know, because I haven't used it. But so basically we chose AWS just because of the IoT stuff. They've been good. The only drama we've had with AWS was the NAT gateways. The default NAT gateways that they provision are like crazy expensive and crazy more than you need. So if you've got a NAT gateway, because we've got containers that are in a private subnet that need to talk out to the internet, and so you can roll your own. They provide the image for a NAT gateway, so you can just get their image and put it on an EC2 instance, the smallest one you want, because we don't have that much traffic. But if you choose to use their service, they provision a huge expensive one that catches you out. So that was a bill shock for us that we got. And once we found that was the problem, it was relieving.
Excuse me.
Yeah.
Well, you mentioned you can roll your own NAT instance, and that's really good for like cost saving, and also you can double up with making a VPN server or what have you. But why did you find that the instance type was for the NAT gateway that they provisioned? Does it show up in your EC2 console as instances or not?
No, it's just a cost.
Yeah. No, I don't think they. Yeah, it's not like you.
Purely an appliance then.
Yeah.
What is the cost for that compared to say a T3 Nano
It's
instance
about
or something?
I'm trying to remember. I got a refund for $200, and I think that was a month and a half of a NAT gateway.
Holy crap! I know that thing's redundant, but that's taking it a bit
Yeah.
far.
Yeah, and we had it across 3 stages, so, you know, it's just, and like at the time, I was like, because we changed our infrastructure, and we didn't, you know, we just started using CloudFormation templates, and I found a really good example of them online and kind of replicated it, and I was just like, I expected the bill to go up, but not that much, and then, yeah, it's only once you start digging and you go, holy crap, why is this bit so much? It's not really doing much for us, but, yeah.
We took in a lot of instances, because sometimes it's cheaper to just give an instance its own IP, even if it's not publicly reachable, just so it can talk out. Like, was it a matter of scale? Were you doing a lot of instances?
Yeah, we had a few instances, yeah.
Okay.
Yeah, we have, yeah. Well, it's in Fargate, so they're not static instances, and they're scaled up and down. So, yeah, I don't know. I'm not that. We'd have to look into it, but that was that we got around it by using an instance, so it was manageable. CI/CD. So we started with TeamCity because the guy I started working with on the project, he was comfortable with TeamCity. And I think there's a lot to be said when someone has experience with a tool. It's worth putting a fair bit of value on that. It can be easy to go, you know, there's newer, better tools, there's web-based tools, but if someone knows it well, then you're going to have a head start. So that's a little lesson there, and that's worked well for us. I've played with other ones, but we haven't ventured too deep into that. So that's kind of towards the end. What were some of the key lessons?
Can I just jump back quickly?
Yeah.
Just when you said, like, what was the winner in the database? None. What was the winner in the other thing? None. Is none this new managed
None. It's upcoming. It's so cheap. They were just equal. I should have written equal.
Oh, so
I hadn't really decided.
So you didn't really care. You just
Yeah.
went with AWS because you were on AWS.
Because of IoT. And we wanted to keep everything together. We didn't want to have split things. The only thing that annoys me with AWS and RDS is that they don't support timescale DB. It would have been nice for us to at least be able to evaluate it, play with it, and that's been like, if you look on the GitHub and stuff, there's issues of it for a really long time, and people are not happy. But I think that's Azure supports it, so that's something that Azure might be a better choice if you really want to have timescale DB. Okay.
So where is Postgres hosted?
So sorry.
Where is Postgres hosted on? You say it's not on RDS?
No. No. So Postgres is RDS is Postgres, but to use the timescale DB plugin for Postgres, you can't do that on RDS. So if you've got a managed database service in AWS, you can't use that plugin because they restrict it basically.
Have you considered Aurora?
Aurora.
Yes.
We have. My co-worker did deploy on Aurora, and we probably will move to that as we grow. The reason why we didn't to start with is because you're forced to have multi-availability zones, so you end up paying for 2 instances, one in 2 regions, and we didn't really think we needed it at the time. But yeah, we will need that. So once we get to that, we'll scale that out. Yep.
I'm still a little bit confused. So you said, so you are using timescale DB?
No, we're not.
You're not.
No. So timescale DB provides what we're kind of managing our time series data by petitioning, and timescale DB kind of takes care of all of that for you under the hood. But I mean, it's an option, but not on RDS. So jump ship early and often is my kind of learning, is that when there's no one paying for a product is the best time to go and try as many different tools as you can. As soon as you get customers on board, it's just like, you've got time goes out the window, and there's expectation, and it's problematic. So when you're early in a project, even though you feel like the people who are pushing you are saying, got to get stuff delivered, it's the best time to be trying different things and seeing what you can learn.
Users always get the way.
Aim to simplify the stack. That's probably something we've done wrong. Maybe I'm not saying wrong, but our stack's pretty complicated, but we are aiming to reduce it. And I think that with with Azure, literally taking out thousands of lines of code. The less code you've got in your project, the less maintenance you've got to do, or not, the less code you've got to maintain. You've got to go through and understand and unravel. So yeah, tools that reduce code are a winner. Don't chase your tail for too long with dependencies. So this is my graphene Jenga library issues that I probably spent longer in it than I should have. We should have jumped ship earlier. I should have just said this is a bit of a dog's breakfast. But that's something you learn, and it's hard to know. Sometimes you just I'll just fix this little bit, and then at the end of the day you should have stopped fixing it and moved on. Be cautious but optimistic about hype. A lot of things get hyped up and they're new and they're exciting. Sometimes they solve problems really well. Sometimes they're solving problems and people think they solve all problems. So just be cautious about it and go, this thing is awesome. And so like GraphQL was very hyped and everyone was talking about GraphQL, how awesome is it? But for some things, it's not the best solution. Similarly to MongoDB, or everyone was wanting to use MongoDB, but it's not the right solution for everything. Just be cautious is the important bit. Don't jump onto something just because it's advertised as doing things. And then questions, if anyone's got any queries.
I have a question. It's about the microcontrollers you're using.
Yep.
Do you have two ways communication, or just one way from the microcontroller to the cloud?
So we have, with the real-time stuff, so these ones here, that one's not talking to the cloud, it's talking to a gateway on the side of the road. And so there's two-way RF communication between them. And then the one on the side of the road is talking to the cloud. At the moment, that's running a Linux box, but it's being redeveloped into a low-power microcontroller.
Is that like a Raspberry Pi or something?
Yeah, it's a big bone. Yeah.
Or like the SPS32 or something? The SPS32? Don't have
I'm not. I kind of like draw my line at the.
All right.
The gateway at the side of the road. That's your stuff. Well, the engineers actually cut me off. I shouldn't say I draw the line. They cut me off.
Fair enough.
You're not an engineer. So yeah, does that answer the question?
Yeah, that's all. Yeah.
So the real-time stuff, how real-time is it? Is it like the dashboard is like update?
Yeah. Well, so that
Is it like polling and WebSockets and
yeah. So like this page here is that's a WebSocket connection. This is over a WebSocket. So this is through Azure. So Azure is it's that's the cool thing about it, is that I could write a query and say, give me a count of events at this stud on the road, and then I can literally change the word query to subscription, and then it updates every time it changes in the database.
Are you allowed to show us Azure and that query?
Yeah.
Because I think that would be really good for a lot of people
Yeah.
to really get it. It's a really fun little system. Are you, do a subscription or something?
So this is like a GraphQL playground. So you can try all your queries and write all your queries in here. So I could go query. I have to think.
Would you be able to make it a little bit bigger?
Yep. Let me go.
Control Shift Plus.
Say again.
Control Shift Plus.
Oh, Control Plus.
Control Plus is because
I'm relatively new to a Mac, so I'm still learning about Mac.
I've been blind for a long time, so.
You thought you'd get away with having to write in live code.
On the spot now.
Live coding pressure.
So what I'm doing is filtering first for real-time sites, which is true. I just want to get the names of the IDs of some of the starts. So go core. So we've got a device. We've got a device mapping. So basically, a device at the road could change over time. So one could fall off, and then a new one could go in. So I'll just get the name of the site because I know what they are. So this is the result of the query. So we've got sites, so we've got one in the US that the US office are testing, so I don't want those ones because they won't be having. So I know this one here, these devices should all be online. So just. What have I done?
2 fingers to the right. Oh,
No, I think I just went back. That's all right, it stores the query, so I'll.
Have you heard of Windows?
It's just a little bit too small, can't quite get it. It's okay, so I'll just do that again. Go to this one and copy one of these devices. And then I'll go query. So that's where it. In fact, I don't need to do this. I'm under pressure and I'm. Yeah, I'll go where. So this is the cool bit about the filtering, is I can filter with all of these functions. So I'm using greater than or equal to, and I'll just, sorry, it's just getting loaded. So I'll just get the most recent timestamp. So this is like a database limit function.
The oldest one?
Yeah. Let's go order by timestamp.
It's interesting to see how much it's been influenced by both SQL and JSON.
Yeah, well, it is kind of like its own query language in the middle.
The way the queries work in Hasura is different to how the queries would work in other. So, like if you were using graphemes with Jenga, these would be very different queries.
Is that right? So it's not
These,
every
this
graph.
is where timestamp. These are all sort of functions of that filter, if that makes sense.
Oh, I see.
So the way it works is slightly different.
It's actually one of how GraphQL is created equal kind of thing.
Well, the way you sort of format it is the same.
Yeah.
But the one of the strengths of Hasura is the fact it does all of this stuff so seamlessly, and the return responses are just so much more powerful.
Right.
It's actually really great.
So these are the.
You might wanna
So
see-
these are the. So this was a query. So when I go like this query, so that's just going to query once and get the result, and then I can change that to a subscription. And now this will update as new ones come in.
You might want to
Order by.
yeah.
guys. You can see those updates.
Or
So that each of those is a vehicle starting or ending going over one of our sensors.
and what kind of data you have there? You're getting there
What do you mean?
because you're just querying the sensor and the timestamp.
Yeah, so that's what we get from the device is a sensor and a timestamp, and then we've got a function in the cloud that runs in a Lambda that goes and takes sensor events for a period of time and goes through and does the math and goes,
Figures out what it is.
what is this? And it's tricky because we have to assume that any one of those sensors could miss a vehicle. So it's not necessarily ordered, it's not necessarily, it doesn't necessarily come in the right order, so you might get the first two and then the third one, the car's parked in a weird spot so that the event doesn't come through to the gateway. So we've just got two and then one comes in out of order 5 minutes later. So then we've got to go and get that range of events and re-correlate it and determine what kind of vehicle it is.
So there's no edge computing at all, eh? You just
No.
dumb systems
Well,
flicking it out?
The edge computing that happens is on the start of the interpretation of the magnet. It's magnetic based and that's all the processing that's done on there is basically the magnetic field changes like this.
And that's
where
just to
it's-
minimise power usage.
Yeah.
That's all. Yeah.
That's kind of always been our company's philosophy is that do the processing later and minimise processing edge. I mean, it would be nice for me if they were spitting vehicles up because I wouldn't have to think about this stuff. But it's
Is there like another field you can add to that, which is like the strength of the magnet or the response time? Curiously.
I would have to get a related model.
No, no.
That's all right.
Well, I guess it's one of the strengths of like GraphQL is just pulling related models like this.
What's it called? No, it's no, actually no, probably. No, I don't get the. I get.
It's company_secrets.
Strength. That's what it is. It is. I feel. And it's not being used. These devices. There's one. So the ones with 0 are older firmware that didn't have this. The engineer just added this last week or something because we wanted to see. So one of the problems we're trying to solve at the moment is figuring out the length of the vehicle because we have all these other technologies, piezo's and things that it's quite easy to work out. But with these, the contact patch, so when it first comes into the range of the magnetometer, it's quite a wide contact patch potentially. So we've added a strength factor to see whether we can use that variable and trying some machine learning algorithms to see if we can infer a length based on known sets of strengths and events. But that's not come to much fruition yet. Yep.
So I wonder about how this GraphQL query gets translated to SQL.
Yeah, you can go and look.
Is it you have to write it yourself, right?
No, that's the thing.
literally the query there.
That's the beauty. This is the query it's built, and if you so it's doing all of the
PG analyzers as well underneath it. It's very
Yeah.
cool.
It's amazing what they've done. Like, what would have taken so much code and time and effort to do yourself in the past is just like out of the box. And the pagination, I want to go and limit from here and offset by this many for every model in the database. It's just out of the box.
So do you imagine, in terms of, do you imagine there will be a need to write your own in order to optimize it? If there's any
Queries?
Yeah.
Yeah. I mean, that's where we write functions because we need to do aggregate functions where we need to go give me a count of vehicles over this time. So that's where we write functions, and then Hazura can, basically map those functions. So you can write views, database views, and they can be mapped to the API. And so then, just to quickly go through the
All right. Oh yeah.
the permission system. So if I go down here to like a site, so you have a permission system in here where you can define who can insert, select, update, and delete. So if you're a user, you can select with a custom check where it checks, are you part of the organisation? And this is the variable that comes from Django. So Django's authentication system puts that into the JWT, and then Jira reads that data out of the JWT and allows you to then use that as your part of your checks. So yeah, it's pretty powerful. We can,
Okay. Because you really want to optimize, you create a view, and then you just
Yeah.
that's
Yeah,
really
yeah.
nice.
write a database view, and then basically, so this page here, these are untracked. So obviously, I don't want to expose Django migrations to the front end. I don't need to get that as an endpoint. And all of my petition tables here, I don't need to get them out. So, and then if you write a view, then it'll come up here, and there'll be a view here that you can track, and then you track that as part of your API.
So that subscription, how does that work with, say, Postgres? Is that like an event base or?
I'm not 100%, but I'm pretty sure it works on triggers, database triggers, where when data gets inserted, that probably has your.
Yeah, it's a hook, I'm pretty sure. It's like a post save or a post commit hook.
Right, so it
I'm
uses that.
pretty sure it's, yeah, so it itself, Sura, I'm pretty sure can subscribe to that because Postgres itself has the ability to add connectors to those sorts of things.
Mm-hmm.
I know someone that did basically the same thing with Django ages ago to try and get it to give like a webhook style subscription.
Yeah.
And that was how they did it. They basically connected to Postgres's like internal hooks to sort of subscribe to that.
And so your optimization, your way of optimizing these queries are basically just using views, or?
So if we have, so with our time series queries, yeah, we use functions, database functions, most of the time at the moment, so that we can pass parameters in.
So effectively prepared statement.
Yeah. And we do that in a kind of tricky way at the moment, which is a bit of a hack that we use. We've created a database table because in Azure you have to have you can only create a function that returns a set of a table. So it has to be mapped to a table so that it knows what the types are, so that when your API is querying, it returns and it knows what types are. So we created a table with a JSON field called return type.
Oh.
So we can use that when we can't like know the types up front. So that's a bit of a hack.
Right.
And that means we don't have type safety on those queries, but that's how it allows us to pass a parameter. Yeah.
Have you found, like, my experience with Sura was that it wrote incredibly good queries already. And I was using pre-version 1 when it was still in beta, and I know you started when it was still in beta.
Yeah.
Have you found that you need to that often?
No, it's only when we want to do aggregates that they don't have, like, and those aggregate kind of ones where you need, and the vehicle, the queries on the vehicle records we have to do through the functions, but if there's anything else, then most of the time Azure's out of the box stuff does what we need. Cool.
Alright, any more questions or you good? Let this poor man go without writing any more code. We'll see what